Bismillahirrahmanirrahim. 4.5 Special cases of integration by parts. Okay, so you can turn to page 2 to 9. Look at to the first question. Integrate of e power of x cos x dx. Okay, you must write the question on the left hand side until the end along with the solution because the expression is repeating. So the expression will appear on the right hand side. Integrate e power of x cos x dx. Okay, this is the formula of integration by parts. uv minus integrate v du. U is equivalent to cos x. Then differentiate u, so you will get negative sin x dx. So what will be your dv? So dv is equivalent to e power of x of the dx. Therefore, v is equivalent to e power of x integrate e power of x dx. Therefore, it is equivalent to e power of your e power of x cos x of the dx now will become uv. Your u is cos x. Your v is e power of x minus with the v. So your v is e power of x. Your du is negative sin x dx. Okay, now let us just rearrange cos x plus, so plus e power of x sin x dx. So we have e power of x sin x dx. So what you need to do with this one, so you have to apply IBP again. E power of x sin x dx. So it will become u is equivalent to sin x. Du is equivalent to cos x dx. So what will be your dv? dv is equivalent to e power of x dx. V is integrate of ex dx. So you will get e power of x sin x. Your v is e power of x minus with the v. Your v is e power of x. Your du is cos x dx. This is the answer for this part. Okay, so we need to combine all here. Therefore, e power of x cos x dx, so this is your question. It is equivalent to e power of x cos x, then plus e power of x sin x. This one should be minus with the e power of x cos x, e power of x cos x plus e power of x sin x minus with the e power of x cos x dx. This is what I mentioned in the beginning, whereby the expression is repeated. So when you move this one to the left hand side, you will get 2 of the e power of x cos x dx. So 2 of the e power of x cos x dx is actually equivalent to e power of x cos x plus e power of x sin x. And then you just want to solve for the e power of x cos x dx. So it is actually equivalent to everything you divide by 2, or we can just put 1 over 2 outside. And since we can factor out e power of x, so let us factor out e power of x cos x plus sin x plus c, because this is indefinite integral. Then this is your final answer. Okay, now look at to the question number 2. Integrate sin ln x dx. So what is your u? U is equivalent to sin ln x. So integrate u, so you will get cos of the ln x. So this one is chain rule. You need to differentiate your x. So in this case, your x is ln x. So you will get 1 over x of the dx. So dv is equivalent to dx. Therefore, v is equivalent to integrate dx. So you will get x. Therefore, your sin ln x of the dx. So now it will become sine of the ln x. Your v is x, so we can put it in front, minus with the v du. So your v is x. So your du is cos ln x 1 over x of the dx. So this one you can cancel out. So what left is x sine of the ln x minus with the cos ln x of the dx. You cannot integrate this one directly. So what you need to do is to apply IBP again. Then cos ln x dx. So when you apply IBP, what will be your u? U is equivalent to cos ln x, differentiate u, so you will get negative sine ln x, differentiate ln x, so you will get 1 over x of the dx. dv is equivalent to, so your dv is equivalent to dx. How to get v? Integrate dx, so you will get x cos ln x. Your v is x, I put it in front, minus with integrate of v du. So your v is x, your du is negative sine ln x 1 over x of the dx. So x you can cancel out. So x cos ln x plus with the sine ln x dx. Your second IBP. So this one is your answer. Sine of the ln x dx is actually equivalent to x of the sine ln x minus, we have x cos ln x plus with the sine ln x dx. So 2 integrate of the sine ln x dx is actually equivalent to x sine ln x minus with the x cos ln x. Therefore, your sine of the ln x dx is actually equivalent to 1 over 2 of the x sine ln x minus with the cos ln x. So this is your final answer.